So the next topic I want to discuss is Venn diagrams. So a Venn diagram is a drawing that helps us represent sets geometrically. To construct a Venn diagram, we're going to draw a rectangle, right? And we can view all the points within the rectangle as our U, our universal set. Then we draw a circle inside the rectangle for each set. The circles should overlap as long as the intersection isn't empty, right? And we can view the points inside the circles as elements of the set. So each Venn diagram divides our universal set into non-overlapping regions called basic regions. And below are the basic regions for Venn diagrams with 2 sets and with 3 sets. So here we have the intersection of these 2 sets. Here we have the intersection of these 3 sets. We can also look at the intersection of each set 2 by 2. We can use these for counting examples. So for the survey of the presidents of the 500 largest companies, right, we saw that 310 had degrees in any sort of business, 238 had undergraduate degrees in business, and 134 had 184 had graduate degrees in business. Remember, 112 had both. We found this a few slides ago. So 112 would be in the intersection. Let's put S be those with an undergraduate degree and T be those with a graduate degree. Now, T, we'll put S over here. S has 238 in it total, but it's already got 112. So I'm going to have 126 left to put in this region. Next, I have that 184 had undergraduate degrees total in T, but I already have 112 accounted for, so I'm going to have 72. All of this adds up to 310, but my universal set included 500 people. So I have to take 500 minus 310, and that's 190. So there's 190 people who did not have any sort of business degree. And that's how we would use our basic regions for counting. Let's do another example. So the results are from an exam taken by 130 students. 90 students correctly answered the first question. 62 students correctly answered the second question, and 50 students correctly answered both questions. So that's what's in the intersection. Next, I want to figure out how much is in F. So if I had 90 students who correctly answered the first question, but I already have 50 in there, I only need 40 more. So see how everything in the circle of F adds up to 90? Same thing is true for S, our second question. That's going to give me 12 over here, because 12 plus 50 adds up to 62. So how many students do I have that answered both? How many would be in F union S? Well, that's going to be 40 plus 50 plus 12. So that'd be 102. Now, here's the thing. The exam was taken by 130 students. So in the rest of my universal set, I'm going to have 28 students who didn't answer the first question correctly and didn't answer the second question correctly. Now that I've filled in my regions, we can answer our questions. So how many students correctly answered either the first or the second question? So that would be the size of the union, which is 102. How many students did not answer the question correctly? That's going to be those left outside of F and S, those sets, so that's 28. How many students answered either the first or the second question correctly, but not both? So that question's saying how many answered the first question correctly or the second question correctly, but not both. So it's just going to be 40 plus 12, which is 52. And how many students answered the second question correctly, but not the first? Well, that's going to be those here, not in the both. That would be 12. Okay, let's take a look at an example that involves 3 sets. So a survey of 100 college faculty who exercise regularly found that 45 jog, 30 swim, 20 cycle, 6 jog and swim, 1 jogs and cycles, 5 swim and cycle, and 1 does all 3. So we've got jog, swim, cycle. So 1 does all 3. That's going to be in the overlap of all 3 of these sets. I then see that 5 swim and cycle. That's going to be this little section over here. So this needs to have a total of 5 in it. So we only need 4 more. I have that 1 jogs and cycles. If I look at jog and cycle, well, they already have 1 in here. So that'd be 0. Next, I have 6 that jog and swim. So our remainder is 5. Now, I know that 20 cycles, if I look at all of C, this whole circle, I've already got 5 in here, so I need 15 more. Then I have that 30 swim, so I look at the whole circle of swim. I already have 10, 5, 1, and 4 give us 10. So I've got 20 in here. Next, I have that those who jog is 45. Well, already have 6 in here, so that's going to give me a 39. My real question is, how many faculty members do not do any of these activities? Well, in order to do that, I'm going to have to add all these sections together. So I've got 39 plus 5 plus 20 plus 1 plus 4. I skipped adding 0, but I could have added 0. Plus 15, and that gives me 84. So those who jog, union with those who swim, union with those who cycle, has a size of 84. But I surveyed 100 college faculty, so that tells me that 16 are left out in our universal set that do not cycle. How many just jog? Well, that's going to be this section right here, which is 39. We can extend our inclusion-exclusion principle to 3 sets. So if I took the union of 3 sets, I need to take the size of each of those sets, subtract each of their individual intersections, but then re-include the intersection of all 3 because I deleted everybody twice and I have to add them back in. The last concept I need to discuss is the pigeonhole principle, and it goes like this. If N pigeons fly into K pigeonholes, and I have more pigeons, right, if N's greater than K, if I have more pigeons than holes, then at least 2 pigeons would have had to fly into the same hole. So I'm going to try and draw a picture. So let's say I have 3 holes, okay, and I've got 5 pigeons. Oh, that's not how you draw a bird. That's how you draw a bird. 3, 4, 5. Okay, I've got 5 pigeons. One of them is not doing very well. I know that 5 is greater than 3. So if I want to put these pigeons in their holes, right, I send the first 3 each to separate holes, but then where do these 2 lonely guys go? They're going to have to shack up with somebody, okay? So let's look at this example. The math club has 17 members. Is it necessarily true that 2 of the members have the same birthday month? Okay, so let's assume that if I take the 12 months, at least one birthday is going to be hit twice, right? So I've got one person here, one person in each month, right? That'd be the best way to spread them out. Well, that means I've only got 12 members. I have 5 left who are going to have a birthday double up, okay? And that's if we had as many options as possible, right? It could be that only 10 months are hit, or it could be that only 8 months were hit. But it means always that 2 of them are going to have the same birthday month. So in section 1.5, here's the homework. I've already made the key, so as soon as I get the homework from everyone, I will post that. Update on the mouse. I think it's hiding under my desktop computer, but I'm too nervous to check, so I'll keep you updated later.